So the internet is not working, and apparently even people outside of um, campus cannot access Blackboard. That doesn't mean we're not having class. We're still having class, but I'm going to read. If anybody texts you and says, "Hey, I can't get online," just tell them that it's not their it's not their. I shouldn't say it's not their problem. It's their. It's not anything they're doing incorrectly. I will record it using my Camtasia software, and then I'll post a link later for them to watch it. But that's just so if somebody sends you a message during class, I can't get online, I can't get online. Okay. So we start on chapter 12, which was talking about statistics. And again, we're only talking about what's called descriptive statistics, which is talking about where the average values are, how much dispersion do you have in your data, but not anything relating to whether one set of data is statistically different than another set of data. You have to take 157 or whatever the equivalent is. So what we were doing last time is we had a list of data that I was starting to create a frequency distribution for. And so I went back and I looked at each number and I put it in a category of what we call a class. And so the result of taking this data and putting each data point in a class, you end up with this information. So the way I came up with the classes, where I looked at the smallest value that I have in my table, I looked at the largest value which I have in my table, which is 134, and then I said, okay, what kind of equal increments can I break that range up into to create 5 to 12 classes? So I chose 5 as the width of the class. So because we were dealing with integers, the class would go from first class would go from 100 to 104, and then I would skip to 105 because there are no numbers between 104 and 105. If I had decimal numbers, then I might say I'm going from 100 to 104.9999 and then 105 to 109.99. So that's why it might appear there's a space here, but there isn't because of the fact that they're all integers. So I started off and I put a little tick mark every time I saw a number that was within one of these classes. And typically what you'll see is that there is a class there's always one class that has more than the others. And usually it's distributed in this way. You've got class 110 to 114 has the most, and the ones right next to it have the next most. And so you have one place where at least looks like most of the things, the largest percentage of points are in, and then you get lower and lower and lower. It's not always exactly lower the next class you go in away from the middle. So what we want to do from this information is we want to create a table, which is what's called a frequency distribution table. And typically it consists of the class information, but instead of tick marks, we put the number associated with the number of tick marks. So I'm going to need 1, 2, 3, 4, 5, 6, 7 plus a header row. So I need an 8 by 3 table. Why do I need an 8 by 3 table? Well, the first column is going to be the class. And so this information we just copy over directly. So between 100 and 104, we're going to have, then let's just fill them in as we go along. So this is going to be what's called frequency. And that's how many times a value fits into a class. So I have 3 tick marks, so the frequency is 3. Now there's one additional column which will be called a relative frequency. We'll fill that in once we fill the entire table in. So let's just go ahead and I'm going to go ahead and fill out the rest of these classes and then we'll come back. So again, you pick your classes so that you have every data point fit in within a class. Each class is the same width, and you want to have between 6, was it 5 and 12? 5 and 12, yeah. So I chose a class width of 5, and I ended up with 7 classes, which is not a bad number. Okay, so now I'm just going to count the number of tick marks I have. So I have 8 in that class. I have 16, next class 13, in the next class 7, 2, and 1. So that's the frequency. And if I add all these numbers together, I think I get 50. So I'll just say add. If you add those numbers, you'll get 50. So there were 50 numbers initially, and they're distributed as such. Now to calculate the relative frequency, that is almost like a probability. If I randomly picked one of these 50 numbers, what probability would be associated with picking those numbers? It's also basically the percent of the 50 numbers that are in each class. So you can show it as a decimal, or you could show it as a percentage. So the way you calculate is you take the number in the frequency column and you divide by the sum, which is 50, and then you do the calculation, which would be 0.06. And we do that for the others. So this one will be 0.16, this will be 0.32, this will be 0.26, this will be 0.14, this will be 0.04, and this will be 0.02. And if you add all those together, you'll end up with 1. Because all of the numbers fit into these classes. So it says basically 0.32 or 32% of the numbers are in the class of 110 to 114, and that's what those numbers represent. So that's relative frequency, because it's relative. It's the number of occurrences relative to the total number of occurrences for all classes. So that's a table, and you could look at that and you could say, okay, well, it looks like the most likely class to be in is this one, and the next most likely class is to be in that one. So it does give you an idea of what's going on. Now we can also do this in graphical form, and the graph associated with frequency distribution is called a histogram. So this information is going to be your x-axis, and this information will be your y-axis. So we're going to show it not as relative frequency being the y-axis, but just the frequency. So I'm just going to sketch one. I'm not going to do one on graph paper, but just to give you an idea of how it looks. So this would be the y-axis is the frequency, and the maximum frequency I have is 16. So I'm gonna put some tick marks on here to make it so the scale fits the data, and that shouldn't be 16, it should be 15. So I just look at these numbers to figure out the scale. Down here we have the class. So we're going to have one class that's 100 to 104. We'll have another class, the next one, 105 to 109, 110 to 114, 115 to 119, 120 to 124, 125 to 129, and 130 to 134. So those are just to describe or identify what the data is that's above it. And then you do a bar graph, a vertical bar graph, and the height of each bar is equal to the frequency number in your chart. So this is 3 units high. The next one should be 8 units high. The next one, 16. The next one is 13. 7, 2, and 1. So that's what's called a histogram. And you label your axis. You would give it a title of some sort. And again, it's the same kind of information that we're looking at here. We're looking at, the level of the different classes, and you would say, well, this one has the most observations in it. If I thought where the average was, I'd figure the average was probably somewhere around here, somewhere on this end, maybe 114, 115, something like that. So what you're going to do for your homework, you'll be given some data, and you have to generate the frequency distribution tables. So you pretty much do what I'm doing here. You get your data, you look at your data, decide what classes you want to create, go through each data point, put a mark when you see it, convert that into numbers as a table, and then take that table and make it into a graph. So that's now for the project for this class, you'll do all that using Excel or Google Docs. And since the internet's not working right now, I'm going to do it in Excel. But typically, if you're good at spreadsheets in one version, they're all pretty close to the same thing. I mean, if I went to a Mac, I probably could figure out how to use whatever software there is. So I'm just going to demonstrate it to you. If you've done this before, don't try to write anything down, because I'll make a video explaining how to do everything. I just want to give you an idea of what somebody might do with this data, because when I worked at Westvaco for 20 some years, number one, most all of our calculations were done using Excel. Most routine calculations, there's some way of doing it in a spreadsheet. I had to buy this calculator to when I came to teach, but I wouldn't use this calculator with all the advanced mathematical functions at work. I would have done it on Excel. They have the equivalent functions. I could use a $5 calculator. So I'd use a $5 calculator that did addition, subtraction, multiplication, division, and then I'd do everything else in Excel. There's a student in one of my other class, and he said he went to Rockbridge County High School, and they have some kind of a capstone project or class, and pretty much they just did Excel. And the reason his teacher, who I know who he is, I know him, he basically said, in the real world, pretty much any math that you're going to do, except for adding, multiplying, dividing, and subtracting, most of it's going to be done in some kind of spreadsheet. And the new class that's coming, not next year, but the year after, Mr. Watkins is working on it next year, and then it'll become for everybody. They're basically saying, we want you to come out of that class proficient in using Excel. So so you should hopefully have some experience with Excel. We're not, we don't have enough time to become super proficient in it, but what I'll do is I'm going to create this histogram, the same histogram that we have here. I'll show you how to do it. Okay, so here's my spreadsheet. So a spreadsheet consists of cells, and they're basically just like a table. you just put the data into a cell, and another use for Excel is to make tables. So typically you have you'll have the table consist of, well, you have headers for your columns. You put your data typically in columns, and so I'm going to say that this column is the class, and this one is the frequency, and this one is the relative frequency. Okay. One thing you'll notice is that if I started writing something in this row, these would cover up that particular row. So sometimes you can what you can do is if you highlight the columns, and then you can just drag this thing and it'll make them all the same width, and that way I can see the whole word. Okay. And so our classes are going to be frequency. Okay, so our classes were 100 to 104, and I don't know what's happening there. Let's try it again. Okay, 105 to 109, 110 to 114, 115 to 119. So I'm just manually entering this information in. Okay, so that's my classes. And then my data was 3. I have to go back and look at it here. 8, 16, 8, 16, 13, 7, 2, 1. Okay. Now, you know, I've already done actually I could have, if I had the data in a column like this information in a column, I could have the spreadsheet do all of it, and I will do that in a second, but right now I've actually started from this point. And the relative frequency, what you could do there is you could use a built-in function. So there's all these different functions, and sometimes they're slightly different for the software, but anything you want to do mathematically, there's typically a function that does it. So in this case, there's the sum function, which adds all the numbers together. So we have 50 total, which is what I said earlier. And then you could calculate the relative frequency by using, if you put an equation in, you put an equal sign, and then I would take this number, 3, and I would divide by 50, and spreadsheets do all their calculations. Their equations are relative to other cells unless you specifically tell it otherwise. So if I were not to do what I'm doing right now, I'll show you. I'm going to push F4, and you'll notice that it puts these little dollar signs in front of the B and the 9. What that means is even if I copy that equation, it will still always go to cell B9 no matter how I change the other number. Because what I want to do is when I copy this equation, I want the B2 part to become B3 in the next cell down, and the next one to be B4. So I want the numerator to change, but I don't want the denominator to change. So to make it so it doesn't change, use these dollar signs to kind of anchor it in the calculation. And so once you've entered the equation one time and you've done it correctly, then you can copy things. And the way you there's a couple different ways of copying it, but you can highlight the cell, and then you come down to the lower right-hand corner, and you'll notice my hollow cross becomes a solid cross, and you just drag it down to how far you want to copy it. And so the equation was copied correctly. And you'll notice, every time I go down one cell, the numerator in the calculation changes from B3 to B4 to B5 to B6, etc. But the denominator always stays B9. So sometimes you have to do that a lot when you do things like that. So that's the table. And how would I create a graph, a frequency distribution graph? Let me just show you how that works. So I would go over here to insert, and I would pick a column graph, and you get all these different choices. So I would pick this one. And what it does is it actually automatically decides what data it wants to use, which a lot of times it's wrong. So you might have to go back and just start from scratch, which I've just done there. I've removed all the input data. And so you have to specify what you want to plot. And it says series name. That's actually the, where's the data? I think, let me just quit for that first. I'm getting out of here for a second. I'm going to move the graph to a separate page. Okay, so that's what it automatically, it's kind of funny. I was talking to somebody the other day about, what software used to be the most popular software for doing things. Nowadays, word processing, Word, spreadsheets, Excel, presentations, PowerPoint. It turned out that those were not the most popular software to do those things initially. The reason we're using them now is because Microsoft kind of used their largeness to make it so everybody ends up having to use Word or Excel. Initially Microsoft was an operating system. That was their claim to fame. And then they said, oh, well, I guess we ought to do something other than operating system. So we'll come up with the word processing, a spreadsheet, and we'll bundle it with the operating system when we sell the computer. When you used to buy a computer, you'd get your operating system, and then you would have to buy all the applications separately. And Microsoft was not the best application. But then they started bundling it with the operating system. And so people started using it from that perspective. And then corporate entities said everybody has to use the same thing. So we're going to use Word because it comes free with the computer and whatever. And but the original really good word processor was called WordPerfect. Anybody ever heard of WordPerfect? You guys never. But when I'm old enough that I've gone through the beginning of all this stuff. And when I was in college, it wasn't actually WordPerfect was not the kind of the standard. I can't even remember what it was nowadays. It was anyway, it doesn't matter. But when I came to work in Covington, 1986, the most popular software for doing word processing was WordPerfect. And everybody was good at WordPerfect. And then ultimately, Word came along. And one of the annoying things about Word relative to WordPerfect was that it would do things automatically. As you know, here I'm going to give you an example. So, when you're doing a Word document, and let's say you want to type in my name, or let's say just any word, okay? What happens is it capitalizes it automatically, right? Which is really annoying because I don't necessarily want it capitalized. So you got to go back and uncapitalize it. If you've ever made a table up, or you've gotten somebody's document that has a table in it, and you try to change that table, you ever gone crazy trying to get it formatted correctly? How do I get it so that these things are in the right place? And there's what WordPerfect used to do was you would be able to see the document, the formatted document, and then you could say, well, let me see all the little code behind it, like tab 3 times, go capitalize something, not capitalize something. All that you could actually look and see what the word processing was doing. And if you saw an error, you just looked at, said, oh yeah, I see why it's doing. It was easy to change the format because you could see what's going on. But Word tried to make it so simple for dummies that it made it so if you really wanted to make certain changes, it just was so. It's still annoying after all these years because you've never lived with anything else, and you're like, oh, it always capitalizes that first letter. It's kind of like when you make tables up with the little bullet points or whatever. If you start to do this, like 1, and then you tab it, and it creates a table. So you put in some letters, and then you put 1, and automatically puts a 2. Well, what if I don't want to do that? What do you have to do? Well, you have to push enter again to get rid of it. There are all these things, all these defaults built in that are really annoying to somebody who's not had some experience. So anyway, back to back to this thing. So one of the things that it does here, it automatically chooses the data it thinks should go in the table. So if you don't like that, then you have to delete what its choices are and start over. Whereas the old version, it used to be called Quattro Pro, was the good stuff, and you would tell it how you want it to do it. It would automatically decide. You would tell it to do what you want it to do, and it would do it. Now what I have to do is I have to go and delete these things, which is annoying. But I've gotten used to being annoyed, so I guess it's just part of the game now. But okay, so you have to specify what you want to call each bit of data. So that's the class. And you push enter. And then you want the values. The values are this column. And you say OK. And you say OK. And so there's my histogram. And again, it did something that I didn't want it to do. Put a legend on there. So I'm going to just delete the legend. So that's my histogram. It looks very similar to what I did over here by hand. So that's my, the things that it's missing are, I'll need to put a label on the y-axis, x-axis. I'll need to put a new title in here because it's assumed the title. So that's, how you would do it rudimentary-wise for creating a frequency distribution table and then the corresponding histogram. But let me just to show you, we're going to go to Google Images and histograms examples. So these are real histograms. Actually, they're Excel frequency histogram examples. And each of them have, the similar characteristics to them. You've got bars, which represent the classes or however they've distributed the data. You've got some x-axis title. You've got some y-axis title. You've got a title for the graph. In this case, they don't put spaces between the bars. They've got some extra information on the graph that I don't know what it is, but you can see they all look very similar. This one is a histogram with multiple, whatever this is, crimson, burleywood, and chartreuse, which is colors, right? Chartreuse is a color. So I'm just looking through it. You can see they all look pretty much the same. They're vertical bars. You've got the class, you've got the title, you've got the description. Let me just put this, what is this? Oh, it doesn't work. Except it did search that. I don't know what the problem is. It seems to be, anyway, you can see lots of histograms. And now it's not reading anymore, so must be going crazy. I can vouch for the fact that histograms are a big deal, and they're one of the most likely things that you'll see as far as going out in the real world if you get into something which involves presenting data. Let me just show you another example of so I'm going to open something here. I've got some data, which I'm just going to manipulate just to show you how it works. When you've done a bazillion of these, you get good at it. these data sets were actually data that I used for a class assignment. So let's just pull them up and see what happens. Let's open that one up. So what I'm given here is a bunch of data. And the nice thing about spreadsheets again is you can get rid of the mundane work. That's the whole idea of spreadsheets. And adding, doing it with 100 data points or 1,000 data points, there's not a whole lot of difference. But if you had to number crunch 100 versus 1,000, it's kind of like Hidden Figures. Has anybody seen that movie? It's about African American women who they were calculators. They did all the calculations associated with space exploration. And before you had computers or spreadsheets or like that, I mean, if you had 1,000 data points versus 100 data points, it took 10 times as much work. Whereas nowadays, to actually crunch the numbers takes a lot less time. So what I'm going to do is we're going to go through the process of what you have to do when you create a histogram. So the first thing you do is you look at your data and find the largest value and the smallest value. And you need to do that because you still have, that's one thing you have to do yourself, is figure out what your classes are. Now, rather than me going through all this data and trying to figure out which is the largest or smallest, one other thing that's really good about spreadsheets is you can order the data automatically. So you can see it's highlighted, and if I go to data sort and say sort column A, okay, what it does is it automatically sorts the data numerically. So I know the smallest value is 33 and the biggest value is 168. So that would have been a lot harder if I didn't have a spreadsheet. Okay, so now what I'm going to do is create my classes. And in Excel, you don't put 100 to 105, blah, blah, blah. You put the number that is at the end of the class, basically. So let's do a little side calculation here on here. So to be able to figure out the classes, what we do is we just write down the numbers, the smallest number and the largest number that we had. So it was, I already forgot, 33 and 168. Okay, so let's write that down as 33 to 168. Okay, so what I want to do is I want to pick classes so that I include every data point and they are equal widths. So if you look at if you take the difference between these two numbers, you'll get 135. So if I divided that into 10 classes, if I had exactly 10 classes, or just approximately 10 classes, I'd have 135 divided by 10, which would be 13.5. So if I went a class every 10 units, I'm going to have more than 10 classes. I'm probably going to have I'm going to actually have, I'd have 13 and a half classes, which would be too many. So that seems too big. Usually you like to pick numbers that are fairly regular, like by 5s or by 10s. So if I did it by 10s, I'd have too many classes. So I could do every 20. So what if I made the classes 20 units width? Well, if I took this divided by 20, so I'm making each class 20 units wide, I would have approximately 6.75 classes. Well, that's within my 5 to 12. So I'm going to choose. So what I'm going to choose is I'm going to have, I'm probably going to start at let's start at 20. So 20 to 40 would be one class. And what I'm going to do is I'm going to put a little minus here. That means just slightly less than 40, so it's not exactly 40. So I do that with all of these. Actually, before I get going too far, we're going to say all the way up to 40, and then this will be slightly more than 40. So I'm going I'm going to go on that side. I'll explain why in a second. Okay, so I go from 60 to 80. I go from 80 to 100, put a little plus there. 100 to 120, 120 to 140, and 140 to 160, and 160 to 180. So you can see every number that I have. 33 would fit in this class, 168 would fit in that last class. What I'm saying here is, if I had 140.000001, then it would go in this class. If it was 40 exactly, then it would go in that class. So this means it's just slightly larger, infinitesimally larger than 40. That way I'm not having overlap. If I said just 40 to 40, then there would be overlap. Okay, so those are my classes. I actually have 8, which is good, between 5 and 12. Now, when you do the spreadsheet, whether you use this or you use Google Docs, the way it does it is, the way I would put this information in is I would do it this way. So typically, the classes, I would put 40, 60, 80, 100, 120, 140, 160, 180. I only put one number down. But what it assumes is when you do the calculations, it assumes that this means everything 40 or less. This one means 60 to 40. So it uses the previous value in your listing to set the classes. So instead of so this one would be from 40.0001 to 60. This would be from 60.001 to 80. So they never get stuck in the same, if they were 60, they would get stuck in this. If it was 61, it would get stuck in there. So that's how you specify classes. Use one number, but it's relative to the previous number that you've written in the group. And let's see how many digits. How many digits was the data to? 1 digit. So I'm actually gonna. Well, we'll do that in a second. We'll need to actually write them out so that they'll work as far as labels are concerned. Okay, so we've got our data. I ordered it to figure out which was the smallest value, which was the largest value. Then I took that information about how wide the data was, and I decided how wide each class was going to be. Each class is 20 units wide. So in Excel, this doesn't come standard, but it's easy to install. It's called the Data Analysis tool. And if I click on Data Analysis, you get this menu with all these kinds of different things that you won't know what the heck they're talking about, but they're all statistics things. ANOVA stands for Analysis of Variance. Correlation has to do with whether one thing is related to another. The only two that we're going to use are, one's called Descriptive Statistics, and that does all the mean, median, mode, standard deviation, all the things that we're going to talk about in the next couple of sections. You'll see the one that says histogram. So that's what we click on histogram, and then you just have to fill out, you just have to specify the range where the various required input data are. So you'd have to specify where the data is in the spreadsheet. It doesn't know unless you tell it. So and you do that by specifying the cells. So this is cell A1. This would be cell A2. Now what I want is I want A1 all the way down to the bottom of the data. So I could do that manually, but it's actually easier to do it by clicking on this little corner thing, and then you just drag and highlight the area. So I highlight, and what it does is it automatically fills in this box. So what it's saying is, I want the data to be from cell A1 to cell A200. It has these dollar signs again, so it's not relative to any. It's always those numbers. Okay, so you push enter when you pick the right thing. This is the class. In Excel they call them bins instead of classes, but it's the same thing. So I'm going to click on this corner part, And I'm going to go back up to the top, and I highlight the classes. And then I push enter. I'm not going to click labels. I don't want any labels. I do want the output, and I'm going to put the output right here so it's close to the stuff there. And I'm going to click chart output. So I want a histogram. So the output range will create a relative frequency distribution, and this will create the histogram. And then I push OK, and it didn't like something. Okay, it says I didn't pick an output range, but I thought I did. Okay, so now I do have an output. Oh wait, it's messed up here. Let me I must have pushed the wrong button. So I have to reselect my input. So my input's 200 data points. I have 8 classes. I want to put the data in a particular cell, and I say OK. And if I scroll back up, you'll see that here's my frequency distribution. So I didn't have to go through and count tick marks. It does it automatically. So what it's saying is that there's one number that's 40 or less. There are 9 numbers that are between 60 and 40. There are 42 numbers between 80 and 60. 59 numbers between 100 and 80. 100 and 80. 50 between 120 and 100. So that's my frequency distribution. Now it should have created a graph somewhere over here. It's probably over to the right or up maybe. Where's my graph here? Let me zoom out. Well, I thought I said to do a graph. Maybe it didn't. Okay, let's go back. Let me undo that. Undo. Guess it's not going to let me do that. Okay, I'm just going to delete this stuff again. Let's try it again. Okay. Data analysis, histogram. Oh, yeah, I did click chart output. I'm not sure why it didn't do it. Let's try it again. Oh, there it is. So there's my histogram. And what I would do is I don't like histograms on the same page because I think it's too crowded. So if you go to layout or design, design, you can create a new separate page for the histogram. So there's my histogram. So what we have the classes on the x-axis, except it's not exactly like I like it because it's just got a single number. And then the y-axis is the frequency. So I'm just going to, once you get to this point, you've just got to kind of clean things up a little bit. So let me just show you how that would work. Again, you'll get some instructions on this. You change the size usually of the fonts so you can see things a little bit better. And so I'm changing the size of the labels so that it's not so small. So hopefully you can see those numbers better now. I'm going to get rid of that label. And the only things that I would have to change at this point are I would change the title to whatever the data represents, and I would put some kind of descriptor here to describe the data. But again, it's a histogram. You can tell that the most frequent numbers between 100 and 80. So let's fix this x-axis. And the way you would do that is you would go in here, and under these I would say 20 to I'll say 39.9, actually 20 to 40. This one would be 40.1 to 60, 60.1 to 80, 80.1 to 100, 101, 100.1 to 120, 120.1 to 140, 140.1 to 160, 160.1 to 180. And I don't really need this because there's none. I picked it so there were no more than 180. And now if I go back to my graph, you'll see that the labels have been changed. One thing is they're a little hard to notice that they are kind of run into each other. It's like, where does one start and one finish down here? So the way I would handle that is you can change the orientation of the label. So if I click on that, and right clicking always works great for choosing things. And what you would do is, let's see, alignment, text direction, and oh, okay. So if I made it at a certain angle, let's see what happens here. We'll try something, see if it works or not. Yeah, see there. So now having them at an angle, you can read them better. So that, they're little tricks of the trade. You can play to present your data more easily, but that's what histograms are. It's just a way of summarizing your data. Instead of having a list of 100, 200 numbers and trying to make some sense out of that, you take it and break it down into just how many times certain numbers occur within class limits. And from that you create your frequency distribution, and then the best thing to do is to show it as a histogram. Now, how would I have used this at Westvaco? Well, I might run some kind of an experiment, and I'll just make up one here. So I'd have some experiment, and this would be frequency up here, and this would be, let's say, some kind of strength property for paper. And I run the experiment, and what I do is I'd have two sets of histograms. I would have, say, a before histogram, might look something like this. Actually, let me rewrite that. Don't try to draw this yet because I haven't figured exactly what I'm doing. I'll use this thing here. Okay, so let's say I'm going to start off with a fairly simple, only 5 classes, so I don't have to draw so much. So you might have a histogram associated with what the paper looks like before you run the test. Before you run the trial. And it's distributed. You're not going to get the same value for every test. That's just the way data is. You get some kind of distribution. And then if I were to then run the experiment, and let me change the color to red. So I might run the experiment, and what I would get is something like this. And it might be over there like that. So, one way to do it would be just to take the average value for the before and after. And then you'd have an average value, and you compare it, and you'd say, oh, well, the second value is bigger than the first value, therefore something happened, and I get some kind of result. Whereas in this case, what I'm doing is I have, the distribution of the data before I make the change, and I have the distribution of the data after I make the change. And you can see that the average value for the white bars is about here, and the distribution the average for the red bars is about there. But you do have some overlap, and you could kind of look at that and say, well, is there enough of a change that I feel confident that what I did was worth the cost or whatever. So that's kind of how you might use it as a way of comparing before and after, rather than just showing an average value. Now, if you really want to know whether these are different or not, you'd have to use not descriptive statistics, but I've forgotten the word. It's no, what's the word? I can't think of the word. Yeah, that was a funny story. So uh, we watched a movie probably about 6 weeks ago, and then we were talking to some friends of ours. I don't know if it's, yeah, we were saying, oh yeah, we saw this movie a couple of weeks ago. It was really good. Can't remember the name. Can't remember what it was about at all. It's like, oh, we're getting old. We didn't know what the heck it was. And so luckily it was on Netflix, so we just looked at our Netflix queue and had to go back and check it out. I don't know how long it would have taken us to remember something. Uh, so it was called Joy. Did anybody ever watch the movie Joy? Yeah, it was nominated. What's her name? Uh, yes, I can't remember her name anymore. She was in Hunger Games. What was her name? Yeah, Jennifer Lawrence. There you go. Jennifer Lawrence was in it, and she got nominated for a Best Actress award for it. It was about this person who uh, was a single mother, but she was always into inventing stuff when she was a kid, and then she had this idea about this mop that was going to, and it's those mops that they're self-wringing mops. If you ever you've bought those in the store, if you ever, they're the kind that have the loops of the cotton loops in them. Anyway, she invented that, and she sold them on uh, QVC. So she was and she ended up becoming a multimillionaire because of that. And it was kind of a dramatization, not a completely accurate, of how she came from being just a barely getting by housewife, or she actually wasn't a housewife, but she ended up, making it big. And so Jennifer Lawrence was in that. Couldn't remember what the heck the name was at all. Did anybody watch the Oscars last night? Anybody stay up late enough to see the disaster that happened? Did you hear about the disaster? What's it? Uh, so Warren Beatty and um, Faye Dunaway were presenting Best Picture. And so they get up there, and he says, okay, the winner for Best Picture is, and he looks at the paper, and he's looking, what's going on here? He doesn't say, and so Faye Dunaway takes it from him. She says, Warren, give me that. Best Picture, La La Land, which was the one that was favored to win. And so the whole cast comes up on the stage, and it's like, oh yeah, we want to. And then there's this kind of going on backwards, and they go like, excuse me, actually, Moonlight won. It's not a joke. They actually did win. What they did is they handed them the wrong envelope. They handed the envelope for Best Actress, which was Emma Stone from La La Land. So when Warren Beatty opened it up, it said Emma Stone La La Land. So he was like, what am I supposed to say? It's the wrong envelope. But then Faye Dunaway says she just looked at it and saw La La Land. So she goes, La La Land. And so then they had to go, okay, sorry, it's actually Moonlighting one. Come on up. And so they all came up, and the other group went off. And so it was kind of like the Steve Harvey Miss Universe thing, where he got he read it wrong. In that case, he read it wrong, but so they had to. But the La La Land people were very, gracious about getting kicked off the stage. They were like, no, you're not going to you can't have my Oscar. Anyway, so those are some examples of frequency distribution. So there are a couple other topics which I'm going to cover later, but stem and leaf displays, nobody does those. We're not going to do this. Anyway, there's a homework for section 1. It's basically constructing frequency distributions and histograms from a set of data. You'll have to do it manually for right now, but ultimately you'll learn how to do these things using a spreadsheet, one way or one or the other. Yeah, usually what I, you know, we still get Netflix through the DVDs because we got a deal where when they changed to the plan where you used to be able to get both streaming and the DVDs, and it was going to go to $10 each, and we're like, oh, we don't want to spend that much money. So they had this special deal. You can get two videos a month on DVD for $5.50. I said that's more reasonable. So we've done that, and they haven't raised the price since we started doing it. And 2 movies a month is enough. Now my wife does not like. She doesn't like stupid movies. She doesn't like violent movies. She doesn't like scary movies. She doesn't like science fiction. So that kind of limits it to what? Yeah, but not really stupid comedy, which is not that many. Chick flicks, yeah. That's she does like chick flicks. That's um, so so it's very difficult to find movies that we can watch together. I got what was it? The Force Awakens, not the most recent one, but the one before that, Star Wars movie. I had to watch it by myself because she's like, I don't want to watch Star Wars. What did you get that for? Well, because I want to see it. Okay, so I had to watch it. So I watched it by myself. And I got The Revenant. Did anybody watch The Revenant? Okay, that was pushing it because that was kind of violent and gross and stuff like that. Yeah, she didn't actually leave. She did sit through the whole thing. But that won a lot of awards. So I wanted to watch it. What I usually do is I either look for chick flicks or I look for stuff that won awards because I can at least say this won an award. So Joy won an award. Revenant won an award. Um, last Saturday night we watched Brooklyn, which is kind of you probably haven't seen it, but it's a good movie. It's about this girl from Ireland that emigrates to the United States by herself in the 50s. And then it's kind of a romancy thing, so she likes that. So that it wasn't a chick flick. I guess it was a chick flick from that perspective. Uh, but but it didn't win an award, so it's always. So this year, I think she probably will not. She will not want to watch Moonlighting or Fences, but we probably will watch. What's the one? The one about the women at NASA. Hidden Figures, yeah. We'll watch Hidden Figures. That'll be acceptable. We'll watch that one about the Indian guy the kid that gets lost and goes to Australia, the one that Nicole Kidman was in. So we'll probably be able to watch that. What else was there? La La Land, definitely. Well, La La Land is a definite. She will watch those kind of things, but. Yeah, my guilty pleasures. What I like. I like. She will watch. Interestingly, she will watch the James Bond movies, but like Jason Bourne stuff. I love Jason Bourne, and yeah, she would never watch that. Um, Taken. I like Taken. That was fun. She. Yeah, the first one was good. The second one was kind of yeah. Yeah, same thing. That's right. I like action. I do like action movies, but yeah, Martha doesn't like action movies. So. Okay, section 2 is measures of central tendency. Most likely everybody's had this. So again, I'm going to go through the definitions quickly. We'll do a few simple examples, and then I'll show you how you do it using a spreadsheet. So the one that's most used is the mean or the average. And this is just to remind me to tell you what this means. This is the Greek symbol sigma, and it stands for summing, adding things together. So this is sigma. That's a capital sigma. Looks like an E, but it actually is a S, more of an S Greek thingy. I know nothing about Greek except letters because I had to do them when you're always using Greek symbols. This is just a trivia thing. That's a small Greek as sigma. It still doesn't look like an S, but it is a sigma. Anyway, but anytime you see this summation thing, this sigma means add stuff together. So the mean of n data items, which means however many data values you have, is calculated as follows. So the mean, and we represent that we show the mean by drawing a straight horizontal line above the variable that we're taking the mean of. So this says the mean of x is equal to, you sum all the values of x together and you divide by the number of data points. Okay. So I think on the next page I've got an example, so let me just delete that data. So let me delete that too. Okay, so I've got 7 data points. What's the average or the mean? Well, the definition, x bar, is you add all the values up. So x is, we could say x is we'll say x is the set of these 7 numbers. Okay, so the mean value would just be 3 plus 11 plus 7 plus 6 plus 5 plus 4 plus 8 divided by the total number of data points. So in this case, n equals 7. We have 7. You just count, how many there are. And then you do the calculation. 3 plus 11 plus 7 plus 6 plus 5 plus 4 plus 8. So the numerator is 44. The denominator is still 7. 44 divided by 7 is 6.289. So that's the average or the mean. Now the numbers I have here I just randomly picked out of the air. They're not any data points. Back in the previous 200, we had 200 data points. The mean, we could kind of guess the mean by looking at the histogram. It would be somewhere where you have the most, typically the class where you have the most values is where the mean is, but it's not always exactly there, but it's close. So simple calculation. It's something that spreadsheets are just made to do. You might have to do this for the exam. I might give you a manual mean calculation for your project. We're going to let the spreadsheet do it because it's going to be a lot of numbers. You wouldn't want to do it manually. But again, you can kind of, if you were to order, one of the things, if I order the data that I have here, so let me just do that. So I'm just taking the 7 data points and I'm putting them in numerical order. So that's numerically. This is, you wouldn't do a histogram of this amount of data because it wouldn't really tell you anything. But just putting in an order, you'd think the middle number is pretty close to the mean, the average of them. So that middle number of this listing in numerical order, that has a special name. That's called the median. This is the mean. So the median, yeah. Let me skip over a few pages here. We'll come back to weighted mean in a second. Okay. So the second most common way of looking at the central tendency of data is the median. And the way you find the median of a group of items is you have to rank the items in numerical order from least to greatest. Again, this is something the spreadsheets love to do. They get all excited about it, you can tell. Anyway, they love to sort data. So if you can do this manually just like I did, but if you have more than about 10 data points, you'd probably like a spreadsheet to do it for you. And there's two cases, depending upon whether you have an odd number of data points or an even number of data points. If they're an odd number of data points, the median is the middle item in the list. That means that you have, say, 15 data points, which is odd. The median would be the 8th number in the list, because there's 7 numbers below the 8th number in the list, and there's 7 numbers above the 8th number in the list. And there's a definite middle. It's like if you took 5 people, you lined them up, you could say which one's the middle person. Obviously, it's one particular person, because you have 2, then the middle, and then 2 more. Okay. Now, if it's even, if you had 4 people, and you say which is the middle person, well, you get there and you find out, well, there's 2 middle people. What do I do? Well, in the case of numbers, you just average the 2 numbers together, the 2 middle numbers together, to give you the median number. So those are the 2 cases, whether it's odd or even. But again, the hard part is just ordering the data. But we'll do that. We'll show you how to do that in the spreadsheet, and how you can come up with the median pretty easily. Okay, let's go back to my data. So anyway, the median in this case is 6, because there are 3 data points less than the median, and there are 3 data points greater than the median. It all was easy once you ordered the data in numerical order. Okay. Now, there are some other kinds of means. There's what's called the weighted mean. And each number can have a different weighting depending upon the emphasis you want to place on that piece of information. The easiest example is grades, calculating grades. If you have a test average of 90 and a homework average of 40, you don't just take 90 and 40 and add them together. Well, say homework's worth 20% and test's worth 80%. You have to weight the test grade average versus the homework grade average to get your final answer, to get your final grade. And I would show you, part of Blackboard has the capability to do that easily. So when you look at your grades, which I haven't put any in yet because we've only had 1 test. Well, we've had 2, but I haven't finished the other one yet. As I put the grades in, you'll see that there's a final average, and that final average is the weighted grade point average. And it does it automatically for you in Blackboard. So what you do when you have a weighted mean is you say the weighted mean is equal to the summation of the different values that you have in your set of data multiplied by the weighting factor associated with those values. Excuse me. And then you divide by the sum of the weighting factors. So in a simple mean, the weighting factors are all 1. Everything's worth has the same value, and so you take the value multiplied by 1, which is just the number, and you add all those numbers up and you divide by the sum. In the case of a simple mean, the sum of the weighting factors is just the number of data points, if you make each one worth 1 unit. So to calculate a weighted mean, you have to know what the value is and the corresponding weighting factor, and then it's just a simple calculation after you do that. So F is the weighting factor, and X is the value. So let's look at a simple example. So what we have is a list of numbers and the corresponding weighting factors. It's kind of like if you were picking car of the year or something like that. You were doing some, or it's kind of like a rubric. Rubrics have numbers, and then each part's worth different amounts. So that's another example of weighted situation. So in this case, excuse me, these are the numbers, these are the weighting factors. So the numerator, I might have to quit here, is the value, the corresponding value times the corresponding weighting factor. So I just take this times that, plus this times that, plus this times that, and so forth, and so on, and you get the numerator is 56. The value times the weighting factors. You add them all up, that's the summation. The denominator, you just add the weighting factors together. So we add all these 6 numbers together, you get 9. And so the weighted mean is just the numerator 56 divided by the denominator 9, and you get 6.2. Let me show you a great example, and then we'll quit. Not a great example, but a great example. So let's say, in our particular class, we said tests are 55%, homework is 20%, the attendance is 5%, and your exam is worth 20%. I could use 20%. I could say the weighting factor is 55, 20. It doesn't matter. And then the value. So then you have to have, these are the weighting factors. The value, let's say I have a test average of 75. I got 100 on homework. I was a little bit lax on attendance, so I got 80. And so these are all based on 100 points. That's how I do it. And the exam, I got a 72. So how do I figure out my final average? It's a weighted average. What I do is I take the value of each part and I multiply by the weighting factor. Now, if the weighting factors add up to 1, I don't have to divide by anything because the sum of the weighting factors is 1, and that's what I would do. I would use the decimal equivalent of the percentage of each one of these, what they're worth. So I take 75 times 0.55 plus 100, which is the value, times the weighting factor, which is 0.2, plus the weighting factor, which is, or the value, which is 80. So I'm here for 80% of the time, times the weighting factor, which is 0.5 in decimal form, plus my value, which is 72, times my weighting factor, which is 0.2, and again, the total weighting factor is 1. If I add all these decimals, 0.55 plus 0.2 plus 0.5 plus 0.2, I get 1. And so my final average is this. Sum of these things. And I get something wrong because I got a number greater than 100. So what did I do wrong here? 75 times, I must have multiplied where I should have added, which I did. And so my grade is 79.65. So that's my weighted average grade. Each grade is based on 100 points, but each part has a different weighting factor. So you can almost, you can figure out how much a homework problem is worth. If I had 20 homework assignments for the entire semester, each homework would be worth 1 point in my final grade. So if I miss 3 homework assignments, that's going to be 3 points in my final grade. You might have close to 20 assignments. So that's why you should do your homework. It can be, just one assignment is 1 point. And, in this case, 79.65. Well, in this case, I can't do any more homework, so that doesn't help. But, if I was at 81 and I missed 2 homework assignments, then that might be the difference between getting a B and a C. Okay, so that's it for today. Now I can go get a drink of water. Hopefully I'll feel better next time.